Okay, so for today's Ed puzzle, go ahead and title your notes Characteristics of Linear Equations. So here is some of our new vocabulary. So you're definitely going to want to write this down. Our first new vocabulary word is slope. The definition is it represents what a graph, table, equation, or word problem increases or decreases by. To find our slope, we have to find the change in the y values and divide it by the change in the x values. Now, slope is a new word, but what slope actually is, we've been working on. Slope is another word for finding the constant rate of change. So if you know the constant rate of change, that is also now known as our slope. The next new word is y-intercept. The definition is it is the starting point of an equation, table, graph, or word problem. So our y-intercept, to find it, okay, easily on a graph is it's always located on the y-axis. And this point we've actually also talked about before. It just hasn't been called y-intercept. This point is what we call our starting point. Okay, our starting point. So we've talked about the constant rate of change. We've talked about the starting point before, but now we're going to add the algebra terms to it, slope and y-intercept. A new vocab word is our x-intercept. Okay, this is the point at which a graph, table, equation, or word problem finally reaches zero. We also call this the break-even point, or you may see it as zero. Another word would be solution. Now, we've seen the word solution in our last unit. Okay, that was when we would find the intersection between two equations. This time, solution in this case is going to mean finding the x-intercept. So the x-intercept is kind of like the opposite of the y-intercept. If the y-intercept is found on the y-axis, the x-intercept can be found on the x-axis of a graph. So make sure to get these vocab words written down. Okay, so now we're going to go through a practice problem together. And when you're done, you're going to go into your Google Classroom to do the practice problems on your own. So let's work through this example problem so you know what you need to do for today. So the problem says, if a diver started at 30 feet below the surface and is swimming up to the surface at 10 feet every 2 seconds, when will he reach the surface? Okay. So if you notice here, for this diver problem, I need to create a table, a graph, and an equation. In order to do those three things, I need to identify these three key pieces: the slope, the y-intercept, and the x-intercept. Okay, so let's go ahead and start. It says if a diver started at 30 feet below the surface. So my diver started at 30 feet below the surface. And if that's where they started, we know that as our starting point. So now they started below the surface. So would that 30 be positive or negative? Negative, good. So negative 30 feet below. Now remember, our starting point is also known as our y-intercept, which is why I'm putting it right here. So I'm going to highlight that blue so I can match my colors here. And I know that the diver is now swimming up to the surface. So they started from the bottom, now they're swimming up to the surface at 10 feet every 2 seconds. 10 feet every 2 seconds. Well, that right there, every 2 seconds, is known as a rate of change. So I'm going to type it in my constant rate of change area because I know I have to find the constant. So this is 10 feet per 2 seconds. In order to find my constant rate of change, I need to figure out, well, how many feet are they swimming every 1 second? So to find my constant rate of change, also now known as slope, I have to divide 10 feet divided by 2 seconds. Well, when I divide 10 by 2, that gives us 5 feet every 1 second. So my diver is actually swimming 5 feet every 1 second. Okay. So I've got to figure out, well, when is the diver going to reach the surface of the water? So notice that I found the slope and the y-intercept from my word problem, but I have not found the x-intercept yet, the 0 or the break even. That's going to be from when I finally finish my problem. When will he reach the surface? Okay. So let's think about what we're comparing here. And in case I can't really figure out what I'm comparing, like my two variables, I pay attention to what I'm comparing for my slope. So it looks like I'm comparing seconds and feet. So in my table, I'm comparing seconds to feet. So time and distance, right? My x's and my y's. So I'm going to also label a graph. So make sure you sketch yourself a graph. We are comparing time in seconds to distance in feet. Okay. So for my equation, it is the same equation that we've been practicing, y equals mx plus b. Now remember, m represents our constant rate of change, and b represents our starting point. So now in our new vocabulary, m represents our slope, and b represents our y-intercept. Okay. All right. So I'm going to write an equation because now that I have my slope and my y-intercept, I can write my equation. So my equation that I'm going to write is y equals, there's a couple of ways you can write this. You can write this as negative 30, I started there, plus 5 feet every 1 second. Or some people like to write it as y equals 5 feet per second minus the 30 feet where they started at. Okay. All right. So I have my equation, and I need to finish up my table and my graph because I want to know, when is this diver finally reaching the surface of the water? Well, I have a calculator, so I'm going to go to my y equals, and I'm going to plug in my equation, negative 30 plus 5x. Okay. So I want to fill up my table. So to get to the table, we go to second graph. At 0 seconds, so right at the beginning, we know where this diver is. At 0 seconds, they're at negative 30 feet below the surface. Okay. And they're traveling up 5 feet every 1 second. My table goes to 2 seconds. So at 2 seconds, I know that the diver is at negative 20. At 3 seconds, the diver is at negative 15. At 5 seconds, the diver is at negative 5. Okay. And I need to know this part right here. When does the diver finally reach the surface at 0 feet? 0 feet represents when the diver finally comes up from the water. So if I look at my calculator, that was 6 seconds. 6 seconds. Okay. So notice that at 0 seconds, the diver was at negative 30 feet. This point right here is also known as our y-intercept or starting point. So I'm going to highlight that so it matches my colors here. Okay. Now at 6 seconds, that's when the diver reaches the surface. So let's look at what that looks like on a graph. So I'm going to be putting some points here on my graph. And I'm going to change the color here. So at 0 seconds, the diver was at negative 30. Make sure that you have your graph sketching. At 2 seconds, they were at negative 20. At 3 seconds, they were at negative 15. And at 5 seconds, at negative 5. And then my last point from my table was at 6 seconds, they were at 0 feet. So I'm going to put that here. All right, and then we're going to make our line to connect to see where this diver was all the way through. And I'll make that a little bit bigger. Okay. All right, so if I look at this graph here, this is where my diver started. The starting point is also now known as our y-intercept. So I'm going to go ahead and label that as my y-intercept. So make sure on your sketched graph that you label that point your y-intercept. And I'm going to put an arrow here going to that point. Okay. When the diver finally reaches the surface right here, okay, 0 represents the surface of the water because they were below water down here. Okay. So when the diver finally reaches the surface, it took him 6 seconds. Now, if I look at this point here, which axis is this point on? It is the x-axis. So because that is the point at which my diver reaches the x-axis, that point is known as our x-intercept. And then I'm going to label that point kind of like my y-intercept. That is our x-intercept. So here I'm going to write our x-intercept is at 6 seconds, 0 feet. Or we can say at 6 feet, the diver, at 6 seconds, the diver is at 0 feet. A little bigger, okay. So if I'm looking at this graph, my y-intercept is always located on which axis? The y-axis. The x-intercept is always located on which axis? The x-axis. That is how I know the difference between my y and my x-intercept. So when did the diver finally reach the surface? Well, they reached the surface at 6 seconds. Reach the surface. Okay. So we found our slope and y-intercept from our word problem. 5 feet every 1 second, negative 30 feet below. We created an equation to plug into our calculator so that we can find out our information. And if I look here at my table, I can find my y-intercept always when time is 0 seconds. And my x-intercept, or my break even, or my 0, is always when the y value is 0. On a graph, my y-intercept is always found on the y-axis. The x-intercept is always found on the x-axis. So that is how I find my x-intercept, my y-intercept, and how I can also find my slope from my word problem or equation. So now what you're going to do is you're going to go to your Google Classroom. Under week 9, you'll see day 1, characteristics of linear functions. And there's going to be this slideshow that I'm actually showing you right now. So when you click on it, it'll take you to this slideshow. And now you have 3 practice problems to work on. Go ahead and let us know if you have any questions, and we will see you in Zoom class tomorrow. Bye.